controls the motor, so it's basically the brain of the car. It's like the EFI and the throttle in a petrol car. It controls how much power goes to the motor based on where your throttle position is. It's also more than that, it's also where all the power goes through from the battery pack. It's got controls of high voltage going through the motor as well.
So it stabilises it?
Yep. So what we've got here at the moment is a test pack, so we haven't got a full racing pack in there. And we've got half the pack here in this brake box and the other half on the other side. You'll see on top it's got the high voltage sticker. So being an electric vehicle, there's enough voltage in there to kill you.
Yeah.
So you've got to be aware of that. Anything over 50 volts is potential. It's controlled by the key. You turn the key on, it tells the brain, hey, I'm ready to go. And it gives you the voltage through to the motor. This may look very small, but the reason we use these is these are very high power, and high energy density as well. A lot more power than lead acid for the same weight. The race battery pack we're building will weigh about 250 kilograms.
Oh, okay.
And that will be probably twice as big as what you see there, but only weigh 250 kilograms, and it'll be made with about 3,000 of these.
Wow.
Welded together.
Yeah. Are they recyclable?
They are. Lithium is recyclable.
Yeah.
The process to do that, there's a company in New Zealand that does it, and of course each manufactured battery there's a different sort of detail in terms of what chemistry goes in there. So
yeah.
Lithium itself is a very valuable mineral,
okay.
and it's recyclable as well.
Yeah. Oh, okay.
If you're driving at motorway speeds, it's got a range of about 200 km.
For how long, though?
So the New Zealand Sports Car Series races are about 9 to 10 minutes.
Yep.
So that's the sort of time.
And then you need to put a new battery in there?
Then you need to recharge it. So
oh, okay.
With a 3-phase charger, you can recharge it in about 2 hours.
Oh, okay.
Yeah.
Sweet.
So the limitation in terms of charging with these batteries is how much current you can get into it. And as you know, most wall sockets, you can't suck much power out of there. 10 amps max sort of thing.
Yeah.
But if you get the big industrial 3-phase plugs, you can get 30 amps or even 50 amps sometimes that you can pull that power out, and that lets you charge it a lot quicker.
Oh, okay.
This body is fiberglass, but you can do carbon fiber, and if you did a whole carbon fiber body, it would cost about 3 times as much and save you maybe 10 or 20 kilograms at the most. Yeah, so I'd rather spend that money elsewhere. Standard 4-wheel disc brakes.
Yeah.
One of the great things about AC motors, as opposed to a DC motor, is that you can very easily do what they call regen braking, which means as you brake into the corner, instead of just burning up the heat from the wheels and getting rid of the energy, it actually takes the energy back into the motor and into the battery, so it recharges your battery as you brake into the corners.
Yeah.
And with a race car, you're doing a lot of braking, you're going basically flat out down the straights and braking as hard as you can into the corners. You want to take all that energy, put it back into your battery pack, because otherwise you're just wasting the energy. Yeah. So that's one of the other reasons why we did AC. Yeah.
Is there any charging on wheels, so when you rotate like an alternator, they actually charge?
Yep. Well, you can do that, but the problem if you do that is the amount of energy you get out of it is less than the amount of energy it sucks from the car. So even though it sounds like you're there, it actually slows you down. Number of different bits of information, but the most important one, that's the battery pack voltage there, 149 volts. So it's about 150 volts, so it's a little bit flat at the moment. And that is getting all its information from this little grey box at the back here. And here there's what they call a shunt, which is just a way of measuring current going through the system, so you can actually see how much current and how much power you've used when you're using the battery. And as a rule, we always just put, they're not going to fully save you from a high voltage shock, but just as a safety precaution, the less skin you have exposed to anything you're doing, the safer you're going to be. And we've also got these high voltage probes. So this is what they call a Cat 4 voltmeter. You can do up to 1,000 volts. Yeah, this is turned off, so there's going to be no voltage here.
Yeah.
So if I do that, so there's the 149 volts, which is exactly what we saw before. And one of the things you can test when you're testing the high voltage pack is completely separate from everything else in the car, so there should be no connection between the voltage and the high voltage battery pack and anywhere else in the car. So like a negative of the battery pack and the other on the chassis. So what we're seeing there, that's millivolts. So that's like